So in section 1.3 of chapter 1, we're going to discuss the periodic table of the elements. So this helps chemists organize the different elements that are found in nature. There are over 100 elements represented on the periodic table, and their position, where they are located on the table, provides significant information about their properties. Each element is represented by a box that provides typical useful data. So here's the elemental symbol of calcium, and it has an atomic number of 20. That tells us there are 20 protons and 20 electrons. And the average atomic mass of a calcium atom is 40.08. The elements are arranged in columns, called groups, and rows, that are called periods. So here are columns, or groups, and here are rows, or periods. So periods 1 through 7, we call them group 1A, group 2A, 3A, 4A, to 8A. The transition metals have a slightly different way of naming the groups. We aren't going to get into that in our class, but we can see here over 100 elements arranged in a very specific order, and that allows chemists to find them and identify information about each element very easily. So here's the periodic table. Again, it might be useful to have ptable.com brought up on your web browser so you can refer back to that during our discussion of the periodic table. So some practice problems. What are the element symbols and the full name for the elements with the following atomic numbers? 10, 8, and 2. So let's go backwards first and find that problem here on our Word document. So what is the full name for the elements with the following atomic numbers? 10, 8, and 2. So to find the atomic number 10, we just look for 10. Ne, that stands for neon. Again, you can look that up in the back of your book. So neon is number 10. Elemental symbol, Ne. And neon. For 8, if we go to find element number 8, the elemental symbol is O. That stands for oxygen. Two, if we look back to the periodic table, that stands for He, helium. So neon, 10 equals neon. Second question, selenium is Se. It's found in some mineral supplements. How many protons and electrons does selenium contain? So now we have to look for Se. It's in here. It's called the main group elements. And we'll see that eventually we get to element 34, selenium. So it's element number 34. 34. And that tells us there are 34 protons and 34 electrons. Remember that the atomic number tells us how many protons there are, and for every neutral atom, there is this equivalent number of electrons. So, as we said before, columns on the periodic table are called groups or families. There are 18 groups, and elements within a group have similar chemical properties. So there are 18 groups across, 1 through 8A, plus 10 in these transition metal region, and atoms within a group have similar chemical properties. The rows then are called periods, and there are 7 of them. Periods 6 and 7 are located below the chart due to space, but they belong after the elements lanthanide and actinide. So rows 6 and 7 have some subsets of them that are located down here due to space restrictions. But essentially you go from barium to lanthanum to cerium to praseodymium, right? And all the way up to get back to hafnium. So these are part of row 6 and row 7. So we can also name some different groups on the periodic table. Within this the main group, we have the alkali metals, group number 1A, alkaline earth metals, group number 2A. Then the main group, group 7A, has halogens. Group 8A are called the noble gases. And we often call this part of row 6 the lanthanides, and this part of row 7 the actinides. And then this group here in the middle of the table, kind of the dip in the table, are called the transition metals, and they are often labeled with B's as part of their group number. So clicker question 1.8, you'll have to refer back to the previous slide. To which group does sodium, Na, belong? So if we look back on the previous slide to find sodium, it's one of the lower numbered elements. It's actually number 11. And we see that it's in the main group. It's in group 1A, and that's called the alkali metals. So, alkali metals, D, is the best choice for sodium. We can also group the periodic table in terms of metals, nonmetals, and some specialty elements called metalloids. As you see here, the blue elements mostly are metals. So most of the periodic table are considered metals. There's a decent amount of nonmetals here, mostly in the main group on the right side, and hydrogen. And then metalloids are clustered around what looks like a staircase here. Boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine. So these are all called metalloids. They have properties both of metals and nonmetals. So let's do a few more practice problems. We'll need to go back to probably this periodic chart. For the element lithium, indicate the family it belongs to, its group number, the period it belongs to, whether it is a metal, nonmetal, or metalloid. So lithium has an atomic symbol of Li, and it has a very small atomic number. We'll find it up here. Element number 3 is lithium. So the first question, the family it belongs to, family is alkali metals. Belongs to the alkali metals. The group number is number 1A. So, alkali metals. Group number is 1A. The period it belongs to, remember that is the row. So what period? This is the row or the period. It's row 1, row 2. It's in period 2. And is it a metal, nonmetal, or metalloid? It is a metal. We can see that because it is a blue. On this chart here, it is a blue element. It's a metal. Okay, the next part of the question. Provide the name of the element that fits the description listed in each case. These are great exam questions. So a group 3A metal that is also in period 5. So a group 3A metal, here's 3A, that is also in period 5. So 1, 2, 3, 4, 5, this is period 5. This is the group 3A metal. I don't expect you to have the names memorized. You can just write IN if you want to label this one. It's indium. So let's just write IN. A halide in period 2. A halide in period 2. So halides are halogens. In period 2, we have period 1. Period 2, F, is the halide in period 2. It's fluorine. Again, we'll just label that F. And lastly, a transition metal in period 4 with 2 more protons than calcium. So a transition metal in period 4, so in this first row of transition metals, 2 more electrons than calcium. So here's calcium. It has 20 protons, also 20 electrons. If we give it 2 more electrons, we move 2 spots on the periodic table to get to Ti, titanium. So the answer here is titanium. Titanium. Okay. The final section of Chapter 1 deals with electrons. Those are the small, very small particles that have a negative charge. and they are located outside of the nucleus in orbitals surrounding the nucleus. So they're located in onion-like layers around an atom called shells, and we number them with whole numbers starting with 1. 1, 2, 3. And as we get farther from the nucleus, the energy of the electron increases. So electrons near the nucleus, such as those on, say, a tennis ball, would be very low. Electrons on, say, the size of a beach ball or a basketball, on the surface of a basketball, would be considered to be high energy electrons. The outermost layer of electrons contains the valence electrons, and they have the highest energy and generally provide most of the physical and chemical properties of the atoms. So the energy levels again are in whole number values starting with n equals 1, and we can see that sort of like a stair step. As we increase the value of n, we increase the energy level of the electron. So hydrogen has an atomic number of 1. It only has 1 electron. It resides in the n equals 1 shell. Carbon, on the other hand, has 6 electrons, 2 in the n equals 1, and it has 4 more higher energy electrons in the n equals 2 shell. We denote the valence electrons, those in the highest level, with the green spheres. So hydrogen, of course, has only 1 electron. It is the valence electron. Carbon has 4 electrons. Those are all the valence electrons for carbon. So electrons in sequential elements, as we move from carbon to nitrogen to oxygen, they're added to shells one at a time. And the most electrons in a given shell is given by the formula 2n squared. So if n equals 1, 2 times 1 squared is 2. We can fit only 2 electrons in the n equals 1 shell. If n equals 2, 2 times 2 squared, 2 times 4 is 8. We can fit 8 electrons in the n equals 2 shell. So atoms within a group on the periodic table have the same number of valence electrons. So those in the first group all have 1 valence electron, but they are in different numbered shells. Full valence shells are particularly stable, and atoms in the group 8A have a full valence shell, so they lack chemical reactivity. So let's just get it. So group 1A, we know, has 1 valence electron, corresponds to the group number, 1A. So hydrogen has 1 electron, lithium is element number 3. It has 3 electrons, 2 in the n equals 1 shell, 1 in the n equals 2 shell. Still has 1 valence electron, except that lithium is 1 row down on the periodic table, so it has electrons in n equals 2. Sodium is a third row down on the periodic table, so it has electrons in 3 different shells. N equals 3 contains the valence electrons. 3 corresponds to the row 3, or period 3, where sodium is. And sodium has a total of 2 plus 8 plus 1 is 11 11 total electrons, just like its atomic number. So here's a practice problem. How many valence electrons do the following elements contain? So I'm going to quickly go back to the periodic table and then go to the Word document. How many valence electrons does barium contain? So first we need to find barium. Barium is Ba, and it's located down here. It's one of the common radioisotopes in nuclear medicine, element number 56. So the question was, how many valence electrons does barium contain? Well, the number of valence electrons corresponds to the group number. So barium would have 2 valence electrons. Where do those electrons reside? Well, that corresponds to the period number. 1, 2, 3, 4, 5, 6. So this is period 6. So barium has its 2 valence electrons residing in the n equals 6 subshell. So barium here, Ba, number is 56, 2 valence electrons. I can abbreviate electron with E minus. And they are in the n equals 6 subshell, because barium is in period number 6. If we look at oxygen, oxygen symbol is O, it's element number 8. And its group number is 6A, indicating it has 6 valence electrons. and they reside in the n equals 2 subshell. Oxygen has 6 valence electrons. They reside in the n equals 2 subshell. So 6 valence electrons, n equals 2 shell. And I think we also included chlorine, so let's look at chlorine. Cl is the symbol for chlorine. That's element number 17. It is a halogen. It's in group 7a. Group 7a elements have 7 valence electrons. So chlorine has 7 valence electrons. They reside in 1, 2, 3. The n equals 3 subshell, corresponding to period 3. So chlorine, 7 valence electrons in the n equals 3 shell. Clicker question 110. Hydrogen and helium, where are their electrons? Where do they reside? So where are the electrons in hydrogen and helium? Requires us to go back to the periodic table. Hydrogen is right here, H. Helium is right here. They have electrons in the n equals 1 shell, corresponding to period 1. Hydrogen has 1 electron, helium has 2. So their electrons reside in the n equals 1 shell, so the first shell. So they have electrons in the first principal energy level, corresponding to the n equals 1 shell. So C is the best answer here. And that takes us to the end of Chapter 1.